Okay. So I think somebody emailed me about this, and I'm really sorry that I forgot to get back to this. But 5-5 homework is obviously incorrect on the sheet. So I am going to assign a few, not too many. Let's see. What would have been really smart is if I would have decided what to assign before doing it. Oh, let's do this. So 245 to 260, every fifth one. I like it. Yeah, that's plenty. What do you guys think? I think that's correct. All right, so let's try a problem out that I did not just assign. Actually, oh no. Let's make it 240 to 260. Okay. Should I start over again? No. We'll do it live. All right. So that's the assignment. So let's try one out. Let's try out number 241, just to be that way. 241 is for, as an example. 241 says that tickets for a train cost $10 for children and $22 for adults. Josie paid $1,200 for a total of 72 tickets. How many kids tickets and how many adults tickets? Okay, so now I know what I almost don't care at the moment about the numbers and the math. I know the two things in English, the two players. The number of children's tickets and adult tickets. All right, so I'm going to call them C and A because I am creative. Now you're thinking creatively. So there are two relationships here as I cough. One of them has to do with money and one of them has to do with number of tickets. So one equation for the system of equations will almost always be a total equation. Meaning if I add my two variables together, it tells me what they should be. So the total number of tickets is 72. So when I add the kids' tickets and the adult tickets, I get 72 tickets. My second equation is going to be all about money, 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 money. Each kid had to pay $10. Get a job, kid. And each adult had to pay $22 because that's the way the world works. Oh, jeebus. And they made a total of $1,200. It'd be really smart for me to put a drink here for myself, but I did not. Too bad. Okay, now I really, really want to get you guys to look for this because this happens decently often. I can divide 2 by 2. And anytime I can make my number smaller, hell yeah, thank you. Let me sign up for that shit. So I divided each thing by 2. Do you guys see that? So if I can multiply each thing by something, I should be able to divide each thing by something like I can in any equation. So now let's see. This thing is so shaky. If I take the first one, now I can look at the first one. Do you see how if I wanted to kill the A's, I'd have to multiply by -11 so that would end up with a -11, but I'd rather deal with the 5. Let me multiply this by -5. So number 1 now becomes C times -5 is -5C. A times -5 is -5A. 72 times -5. Oh shit! I think it's -360. Yes, okay. That would be smart too. A drink and a calculator. It's amazing, Jeff. Well, I'm learning. So now I've set it up. And in fact, just to point this out, you did not have to divide by 2 here. You could have multiplied by -10, and that would have killed that. But just, if I can, why not make my numbers smaller? So now I've got the C set up. So when I add these two equations together, those cancel. 11A minus 5A is 6A. 600 minus 360 is 240. Woohoo! And it looks good because that 6 goes into 240 40 times. That means there was 40 adult tickets sold. And then to figure out the kids' tickets, I'm going to definitely use the first equation because it's got the least amount of stuff going on. Oh boy, here we go. C plus A, which is 40, equals 72. Subtract 40. C is 32 kids running around. At least you got more adults, but you're having to play zone. Well, you can do man to man, but man, those 32 kids, you got 8 extra adults, but they're going to have to run around. Anyway, I'm going to stop talking about defensive strategies against kids. All right, so here's the whole problem. Let me see. There we go. Not too bad. There we go. And one more time. Here is the assignments, section 5.5. I did not assign very many problems at all. So do them, and let me know if there's questions. All right, I'm going to pause. I think I've learned. I'm going to erase this. It's all going to be gone. Ta-da! Okay. Let's do one more here real quick. Here we go. All right, let's talk about 252. This is still section 5.5. Oh no, I wrote on there. Does it come off? Yay. Okay. 252 says, how many pounds of nuts for $6 a pound and raisins for $3 a pound should Kurt Cobain combine to obtain 120 pounds of trail mix that costs him $5 a pound? Okay. This one's got a nifty little twist in it. So there's an idea of money and there's an idea of pounds. And it says, how many, where'd you go? How many pounds of each? Okay, so I got pounds of, and of course pounds is LBS, of course. I forget why, to be honest. It's probably some Latin word. Pounds of nuts and raisins. Oh, yeah. That's the word raisins. So I'm going to call this, let's be crazy. Let's call this N and this R. That's insane. So the first equation again. The first equation, let me see, can I fit them over here? No. Crap. The first equation is going to be a total equation. The pounds of nuts and the pounds of raisins combined. Your powers combined. 120 pounds. Trail mix. This is a really boring trail mix, but oh well. And then, so that's pounds, pounds, pounds. Now watch this. This is where things get a little interesting. Each pound of nuts is $6. So 6 times the number of pounds of nuts plus raisins is 3 pounds, $3 per pound times how many raisin pounds I've got. That was weird, raisin pounds. Now here's where it gets weird. You want the end result to be $5 per pound, and you want to have a total of 120 pounds. So notice, money per pound times pounds, money per pound times pounds, money per pound times pounds. So now this is a pure money equation. So let me see. So 2, just to clean this up. Well, just to notice again, I'm going to do this. Can you see how you can divide this by 3? So I'm going to divide by 3, and I'm going to get, number 2 is going to look like this. 2n plus r equals, let's see if you guys can do this. 120 divided by 3 is 40 times 5 is 200. Woohoo! I don't know why I went way over there. Okay, so these are the 2 equations I'm working with now. Notice how the r's just want to die. If only one of them was negative. So let me take the first equation and multiply by -1. So then the r's will kill each other. I get negative n. N times -1 is negative n. R times -1 is negative r. 120 times -1 is -120. Die r. All right, I'm getting a little loopy. I'm sorry. 2n minus n is n. 200 minus 120 is 80. So I got 80 pounds. Does that make sense? Yes, 80 pounds. What I was making sure about was I looked real quick to see how many total pounds I was supposed to have. Because obviously if I got more than 120 here, that would make no sense. So on 80 pounds of nuts, I'm really sorry. I don't know. I keep saying it that way. I'm sorry. And then how many pounds of raisins? I can just use the first equation, put 80 for n, subtract 80. I get 40 pounds of raisins. Let me say it the same. Raisins. Yeah, there we go. That's all I'm doing. Okay. Can you guys see that? Let's see. So let me kind of scroll up for the whole problem. Give your parts names. Identify the two relationships. Very often it's going to be a total equation and then money or something like that, where the two variables just add to be something, and then it's going to be some multiplier to make something. Oops, that was the equation. And then get one letter, and then you can plug back into either one. I just chose this one because there was nothing going on to get the other. Oh, scheisse. To get the other answer. 40 pounds. It's okay, Jeff. They know what it is. All right, I think that's good. Yeah, that averages out with the other one that was a little bit longer. All right. Bye, everybody.